All right, so first I think we're gonna go down the line and just introduce ourselves. So my name is Max Welliver, and I'm a junior, and this is my first year on the team. Can we grab one of those mics over here?
Hello, I'm Ali Kareem, and I'm a freshman at RAeS Aviation High School.
Hi, I'm Ethan Palasok, and I'm a junior at RAeS Aviation High School.
Hello, my name is Jeremy. I am a senior. It's my second year on the team.
Hi, my name is Nigel Barnett. I'm a junior, and it's my first year on the team.
Hi, my name is Joseph Gazebo. I'm a junior, and it's my second year on the team.
Hello, my name is Lauren, and I'm a senior, and this is my first year on the team.
Hi, my name is Nick. I am a senior. This is my second year on the team.
Hi, my name is John Wick. I'm a senior, and it's my second year on the team.
Hi, I'm Alexander Keller. I'm a senior, and this is my first year on the team.
All right, so welcome everyone. Thanks for coming out tonight to hear about our project that our school has been working very hard on, both before and after school. So hopefully you had a few moments to see our winning solar car in the lobby area. Like I said, my name is Max Welliver. I'm a junior at RAeS Aviation High School, and I'm also on the board of the Royal Aeronautical Society. So thank you to the Royal Aeronautical Society and the Museum of Flight for hosting our presentation tonight. So I'm very proud to say that last year's team from RAeS Aviation High School brought home the first place trophy. Tonight we're excited to share with you our team's journey to becoming the 2019 National Champs, and also to tell you a little bit about what we've been up to this year. Now before our team captain Jeremy Boyle gets us started, we wanted to share with you a new promotional video. One of our team members, Alvin Mislang, who's our photographer tonight, what he came out for us.
Again, my name is Jeremy Boyle, and I'm one of the team captains of this year. So before we go deeper into our journey through the 2019 Texas Challenge, I'm going to talk about the challenge as an overview. So this happens every year in July. It happens either in Texas itself at the Motor Speedway or as a cross-country event, and it is the largest event in the Western Hemisphere. There are also awesome events happening in Australia with college teams and all over the world, so expect to see solar cars in the future, and this is something that's not going to stop. So there's going to be 4 days of racing, and before that, a few days of scrutineering. How does this work? This they'll talk more about, but it's hard work to make sure the car is prepared and ready for the track. So I'm going to be showing a couple of competitors' cars, and then we'll see footage of the car itself. So for a lot of teams, this is a legacy. They build a car every year, and they have had years and years of building this, refining their skills. And for us, last year was our first year. We had never done it before. We had built a wind turbine, and we were confident in ourselves, but in truth, we hadn't built anything this big. And so it was our very first year. And as you heard, we're really excited to say we took first place in our rookie year. And so these are a couple of people that we were up against. Next up, we'll see a video of our car rolling onto the track. It's a really proud moment for our team as we had put in months and months of work and hours of work into getting that car up and working, testing, designing, building.
We're good. We're gonna slow him back after this lap. BMS is saying we're around 12.
Back 2.5.
Yeah.
Again, hello, my name is Nicholas Nemeth. I'm one of the senior members of the RAeS Green Energy team, and I'm here to share more about some of the school and the team competition itself. So we are located at RAeS Aviation High School, right across the street over there, and our team consists of 19 students, 7 returning and 12 new, across all age ranges. In addition to age ranges, we have people who are experienced catters, programmers, machinists, to people who've never stepped foot in a shop before. We love this because this allows us to teach new skills, new people, and it gives us a wide variety of ideas that we normally wouldn't have. In addition to a new team, we've also been pursuing more outreach opportunities like this presentation here. We're super glad to be here, and also different companies for help with our financial situation.
The Solar Car Challenge teaches students a variety of skills, whether it's in manufacturing and design, programming and electronics, aerodynamics and drag, physics and computers. There's a variety of skills that are applicable not only to engineering, but to aerospace as a whole. Many people who join the team don't know a thing about cutting metal, about welding, about programming, about making a car in general. But they come in not knowing much, but they leave having the confidence and the skills to advance their place on the team and in the world for their career. Personally, I came in last year as a sophomore not knowing much about how to cut metal, how to work in a shop, how to work with a team at all. But I'm emerging as a member of the team and a leader on the team to advance the car, and advance the team, and advance myself personally. So I'm very proud of that, and I'm very excited for that.
So for our challenge, we had 9 months, which is actually a little bit less time than we had last year, but this is 9 months to plan, design, build, and finally test our car. We do most of the building in-house, with only a little bit of the more delicate pieces machined outside. And we also do most of the testing here, either on East Marginal, the lot next to our school, but we also go to the PACCAR track in Burlington. They are generous enough to let us use their track that they use for testing their trucks, and so that's also a really great way for us to see how our car performs on another track. So here we have some of the photos of our design process last year. Starting up here at the top left, this is one of our members, Teddy. Basically, what started off as our car, nothing more than a couple pieces of metal welded together. As time progressed, we slowly got more and more pieces. This is our team captain last year, George Seidels. We have finally our motors attached. We have our makeshift floor of plywood. We also have a steering wheel. Moving on here, we sort of have our crush zone, our roll bar, some more of the brakes and motors. For the electronics side, here we have one of our senior members, Anna Horner, last year, working on the batteries. These are the batteries that we actually used for the car. This is a prototype steering wheel that we had. We did eventually change one to a steering wheel that we could remove that would help us later on in scrutineering, but we did keep these switches. This is the final dashboard that we had. And these switches allowed us to turn on all of our electronics. It's also how we switch into reverse. Here we have George again working on our solar panel rack. You can see the final version up here. What he's working on there is actually the tilt mechanism. We decided to make this, that way we can charge our panels most efficiently wherever the sun was located.
Testing is one of the most important parts of our year. Knowing how the car behaves in both efficiency and in safety is important for drivers to know before they go and drive. So for efficiency, we always want to know what the best way to drive our car is. So by using data and telemetry that we gain from the car to the driver into the pit, we can identify the best speed to go at to sustain our miles and to extend our mileage over the race. For safety, drivers need to know the car like the back of their hand. They need to be able to operate in certain scenarios and emergencies to be able to operate in case something goes wrong. So safety, again, is one of our biggest priorities while racing, so we always try to stress that. Last year, we had about 500 miles of testing before we went to Texas. So being able to drive in the car and see what it feels like and how to improve it and what goes wrong, what goes right, was important for us before we went to Texas. And this was about double the amount of miles recommended and probably more than most of other teams of the race. So, big upper hand.
So another big challenge we had was actually getting the car to Texas. Texas is a long drive, and it took a lot to get it together to get the car down there. We are the only team from the Pacific Northwest that participated in the competition this year, so we are the team that drove the furthest down to Texas to get there. It's about a 5-day drive and over 4,000 miles, and fortunately, last year we had someone volunteer, one of our past students' dads volunteered their car to trailer the solar car down to Texas, and we had multiple pit stops along the route, saw some friends and family. It was overall a good time, but still a very arduous journey. As for how we got the rest of the team there, we just flew the rest of the team down because nobody really wants to drive 5 days, you know. So we just got a group deal from Alaska Airlines, and we all flew down there and met up with the car and met up with the team, and that's how we got down to Texas.
So Jeremy briefly mentioned this, but the first, we have 3 days of trip are scrutineering. And so this is to make sure that both the car and the driver are skilled and safe enough not to pose a danger to themselves and the other team members. Here we have our car going through what's called the tilt test. This is to make sure that on the actual bank of the track that our car wouldn't flip over and crash. While here we have one of our team members just driving around getting a scope of the track. Other scrutineering stations include a slalom course in which the driver and every potential driver would have to get in the car and drive through a course of cones. Then at a random point they would be told to completely stop the car, shut it off, and then get out within 15 seconds. This is to simulate in case of a fire emergency. Another scrutineering station took place on the track where we'd have to simulate a breakdown, so that required all of us to get in our truck or trailer and simulate what would it be like if we had to retrieve our car and driver off the track in case of an emergency.
So one of the reasons, aside from our efficient aerodynamic design of our car, was our race strategy. We spent a lot of time planning out how we're going to drive the car at the race so we can get the most amount of laps and eventually win the race. That was our goal. So we have to take into account that here in Seattle, we don't get as much sun as they do in Texas, right? It's cloudy half the year. So on average, we generated about 1,200 watts here at home, but in Texas, we could generate about 1,800 watts. So that's a big difference, and we had to take into account for that in our RAeS strategy. And the way we did that is we had an onboard telemetry system. So this is kind of a screenshot of our dashboard, which we updated with live data, such as how much power we're drawing from the battery, the temperature, how fast we're going, all that good stuff. And all of that is sent to this dashboard here, which is a website and an app that we had on our phone through a Wi-Fi hotspot we had on the car. And what we did with this data is we created estimated values of how much power we're going to generate from the sun in Texas. So for example, at 10 a.m., we looked at the weather report and we saw that there's not going to be any cloud coverage. So we estimated that we're going to generate about 1,400 watts and our battery should be at about 80%. So we had these lists of values set up in a spreadsheet, and then we compared them to the real-time values which we got from our telemetry system here. And that was able to tell us if we needed to speed up to draw more power or slow down to conserve some power so we could drive the furthest. Another important factor of our RAeS strategy was renting out a condo, which can be seen in this picture up here. So this condo provided oversight of the whole track and allowed us to look out for any safety cautions or see what's going on overall. And this is kind of where our base camp was for all of the data analysis and RAeS strategy. So we had 2 students up there giving real-time updates to the driver over radio, telling them speed up, slow down, what's going on with the race. And this picture here is kind of an overview of our dashboard. This is what we mostly looked at, as this updates real-time as we're driving around the track. So this gauge right here, these 2 first gauges told us how fast we were going. This gauge right here told us how much power we're drawing from the battery. This gauge right here tells us the voltage of our battery, which is basically like the percentage of our battery. It's just pretty hard to calculate the percentages of lithium-ion batteries, so we just displayed the voltage. Down here is how much power we were generating from the sun, so we always knew how much power we're generating and how much power we're drawing, so we could always balance it out and not draw too much from our battery. These last 2 here, this is just a net power. So basically the solar power minus the power we're drawing, and then this is just the temperature of our battery right here.
Next, we're going to move on to the work we've been doing this year. We've learned a lot of lessons from last year, and one of the most important lessons we've learned is about organization. We realized that our team can be much more effective if we are much more organized and have much clearer tasks and ideas of what to do. So up on the screen you can see our main sub-teams, and what we've done different this year is that we've assigned a lead to each of them. And the lead will get to talk more about their team in depth here, but I'll briefly go over what their roles are and how they all work together. First up is our outreach team. This team is crucial and works a lot to get the word about our team out into the public, get us sponsors, and to improve our community engagement. Next up is the electrical team. The electrical team is crucial for any electric vehicle, and without them, we wouldn't be able to do all the great work we do, get the battery working, get the motor running, and things like that. That's all the work that's done by the electrical team. They also do a lot of great work in programming and the digital electronics. So there's a difference between our analog electronic side and our digital electronic side. Analog works a lot more with the movement of voltage, relays, and things like that, whereas the digital side is much more about telemetry and programming. Systems integration, this team does a lot of great work to make sure that systems are all working together. This is, in a way, it's similar to an airplane. There are all kinds of systems working together. There are wires running all throughout the car, and in no way can any wire be cut by any kind of moving part, any suspension moving. It can't cut any wire, or else we will lose power. And so the systems team is making sure that every other team is working together effectively and is able to build a nuanced and working product. Lastly is our structural team. This team does a lot of work with metal and building the structure of the car. They're building our chassis, They're putting together our suspension, they're welding, they're cutting, they're in the shop all the time. Additionally, they're doing a lot of great design work on CAD, so this is one of our strongest teams, and we learn a lot from them, and we're really proud to have them. We're really proud to see what they're doing.
So displayed here are just some photos of some people who have really influenced us in our journey to building this year's car. So first and foremost, we would like to introduce Dr. Lance Met, who is just sitting right there. He's our mentor for this team. So yeah, he's our mentor on this team, and he's been on this team since the very beginning, and we are very grateful to have him here because he has put in countless hours to make sure that we construct a successful car, and he always challenges us to work to the best of our abilities, which is something that we are very thankful to have on our team. In addition, we have also had a great opportunity to work with Boeing and improve our design on our car. So we have planned several meetings with Boeing aerodynamicists to create an outline of the ideal aerodynamic shape, as well as the materials and manufacturing techniques as how to create this aerodynamic skin. And so in the middle there we have Les Tardif, who is a Boeing materials engineer. And lastly, we would like to shout out Charlie Lyford, who we met at the Museum of Flight Pathfinder Gala, and he was able to tour our school, and he really liked our shop and our makerspace. So he actually invited us to his shop in Issaquah, which is T0 Racing, which is that photo on the right.
So I'm here representing the outreach team. We start really early in the year, even before we start thinking about designing our car, making sure we can finance and pay for that. So we'll be reaching out to our local community sponsors in addition to year-over-year sponsors from some of our top sponsors, like the Aspen Community Foundation, Electric Impact, in addition to our own Parent-Teacher Student Association. So of course we're really thankful for them for really making this project possible, but also supporting us just on a day-to-day basis, keeping our team running. So thank you to all the sponsors listed above. One of the things that we're doing here is we're really representing the entire Pacific Northwest. So you'll see all of their logos on the side of our vehicle, in addition to our website, as we're posting updates on our current car progress as we go from there. So again, thank you to our sponsors, but also check out our blog posts to watch as the car gets assembled.
Next, I'll talk briefly about our design philosophy. This Venn diagram, is a culmination of the beliefs that guide us through our design process. The first one being safety. This car has people in it, and it's our own making, and we wouldn't make anything that's not safe. So when we're designing things, we look at things such as electrical safety, high voltage, and things like structural safety, the roll bar. We talk to race car manufacturers and get their advice on how to make a car that's safe in any impact. We have not had any impact, but of course we build as if there's going to be one. Next up, reliability. You can see by the nature of our events that the car must be capable of driving long distances. It drives hundreds of miles around the track, and before that it has to go through a lot of testing. So the car cannot be designed to fall apart at the first 100 miles or things like that. So every design decision has to be something that's going to be reliable and something that's going to last. Our third priority is efficiency. Efficiency is multifaceted. It shows up in our electrical efficiency. We look at our voltage drops across different systems. We look at our aerodynamic efficiency. Probably the most important thing is our drag, how much drag we have. We look at how do we reduce that drag. And also we look at our efficiency in our systems, in our bearings, in any mechanical system, and look for ways we can reduce that, because any loss of power in one lap is just going to compound itself over and over and over in the next laps. And so any change in efficiency, even as small as it may be, is going to make a big improvement in the long run.
Yeah, so like what Jeremy said, going about an efficient making an efficient car has been one of the leading factors in the design for this year. It's led to some of our more major changes. So going into this year, we based the design off, and we took inspiration from world-class solar car teams like Team Agoria from Belgium, which won the Australian solar car competition. This is where we've come up with our new two-pod catamaran design, which we'll show shortly. This features a brand new integrated solar panel, which we made for the purpose of decreasing drag and increasing the overall efficiency of the car. So we kind of have this useful diagram here to show the main differences between the design of last year's car and the design of this year's car. So one of the more major design changes is we moved from a 3-wheel car last year to a 4-wheel car this year. This is based on our decision to make an integrated solar panel. We needed the 4 wheels in order to have a stable base for the car, in order to take maximum advantage of the maximum area of the car, which is why we've had, it looks like a large rectangle with those 2 pods on the bottom. So you have the smaller pod on the left, which contains our different electrical systems, our driven wheel, and all of our other components. And in the larger right compartment, you can see you have the large canopy sticking outside for our driver. That has all of our safety systems, the roll cage, and all the important structural components that protect the driver. One of the things that we're most proud of this year is our change in how we design the car. We put a lot of forethought and design choices and kind of brainstorming into how we build the car this year, and we feel that that'll make, while it'll take a little bit longer for us to get the final product made, we feel like it'll lead to an overall higher quality product for us to do well this year.
Alright, so as Nigel previously mentioned, we have used some computer-based Autodesk software, such as Autodesk Inventor, to help us out with design. Autodesk also produces another program called Autodesk Flow. This is a digital wind tunnel that can import shapes and files to analyze aerodynamics. The pictures shown here are some screenshots of what the program looks like. Our goal is to achieve the lowest drag coefficient possible by making small changes to the aerodynamic shell of our car. By designing the car like a catamaran, we reduce frontal area, leading to that lower drag coefficient. Our current design has a drag coefficient of about 0.27, similar to that of a Tesla. And to put that in perspective, a Clark-Wire foil has a drag coefficient of about 0.045, which is around 6 times less than our car. And in talking with one of our mentors from T0 Racing, Charlie Lyford, he instructed us to spend the same amount of time on the bottom of the car as we do on the top. So by eliminating any raised fasteners or screws or other objects that may cause parasitic drag, this will aid in achieving that lower coefficient number that we want. And with the new design of morphing the solar panels into the shell of the car, we lose around 100 watts of solar power due to shading, but our improvements in aero efficiency will offset this loss.
Hello again, I'm Ali Kareem, a freshman this year joining the team. This year we're focused on planning out our car and making sure our car is most efficient and fits within all specs and regulations. We've also focused on adjustable seats so we can accommodate drivers of all heights and make sure the overall driver interface is well. We've also designed our suspension in-house and is unique to the competition. This is used as a shock absorber for a smoother ride for our drivers and is specific to our car.
Hi, I'm Alexander, senior on the team, and one of the big design choices that we made this year was the material that we're going to make our chassis out of. Last year is a full steel frame, and this year we're doing the same. At first we were looking at aluminum, but with aluminum we ran into 2 major problems. The first one being that although the frame can be made out of aluminum, the roll cage would have to be made out of steel, and you can't weld metal to aluminum, you would need a bimetallic insert that would be able to, so you can weld them together. The second would also be that welding aluminum is way trickier than welding steel, and something maybe a little out of our reach right now, but I'm sure we can work on it in the future. Looking at welding more specifically, we want to make sure that it's such a huge part of our car that so many people can do it, and welding steel and allowing everyone to be able to weld is just such an awesome part that we can get everyone involved in. In addition, we're using a lot of different composites on our car, and one of the ways we're using those are for our chair, using fiberglass and epoxy.
The top photo shown on the slide is one of our team members, Teddy. He's focused on practice welding for the preparation of our chassis. And on the bottom picture, you can see one of our team members, Highland, working on the mock roll cage.
On the left here, we have a picture of one of the rear suspension modules. So this is not fully complete, but eventually what will happen is one of the rear suspension will be placed on here with the wheel. And then on the bottom right there, that's actually a very close picture to what we have right now of the frame of our car. You can see on the left-hand side of the picture, one of the catamaran sides that is going to hold the battery and the electronics. And then on the left there, our truck show will be Nigel sitting in there so we can take measurements and make sure that our cockpit is set and ready to go.
We've talked a lot about our design and how we got to where we've designed this car, but I'll talk briefly more about our materials. We've talked about composite material, and this is something we're really excited to look at. We started the year off and we looked at our composite and said, wow, anything is possible. And that is true. And we also looked and said, we don't quite have the tools we need to do everything right. And so we're going to use composite for parts that are adequate, such as we talked about the chair, the solar panel rack, but we're also learning the advantages of steel for its simplicity. And so one thing we're learning is that just because it's flashy doesn't mean it's the right material for us. So we're learning the pros and cons of each material. So we're excited to continue our car, make it lighter and lighter as we go forward. Next up, the solar panels. Now these solar panels are custom made, and I was one of the designers of them both last year and this year. And so what's really interesting about these is that it's not like we just specify a rating. We don't just say, oh, we want 48 volts and give us like 200 watts. It's something that we design ourselves. We look at the cells and we make the arrangements. We look at the shading, the diodes, the patterns, and we build it specifically for our car. And then we send them off for shipment. Now our tires and motors and a lot of our other systems, they're mechanical in nature. What's interesting about them is that a lot of them come from electric bikes. And this is because we do use some car parts, but for the most part, car parts are too large and are somewhat heavy for our needs because our car weighs in about 600 to 700 pounds. And so for a lot of things, electric bike parts beefed up a little bit are adequate for our strength and do everything we can do right. So for example, our hub motor and our data analog system from last year were based on bike parts. So this is really interesting how we are able to combine car parts and bike parts into this hybrid we have that's a very light electric vehicle. And as I've said before, electronic sensors are crucial in giving us that data that we need to successfully go around the track, to finish the day with just enough battery, just in case anything goes wrong, but to have put out all of our energy onto the track and given as much distance as we can. So all these components are really crucial in getting us, and we've been grateful to have so many materials donated to us by Boeing, also, and by the Gill Corporation. They've been really helpful in getting us these materials such as composites and advice on how to implement these into our design.
Alright, now on to the electrical and solar panel design for this year's car. Our core electrical system is going to be pretty similar to last year's. system, as we had really good reliability. We had very few issues with our electrical system. So what I mean by our core electrical system, I'm talking about the battery, the motor, and the motor controller. We are changing our battery a little bit as we bought higher capacity 18650 cells, so we can pack more energy into a smaller space and we lose some weight. So last year our battery weighed about 65 pounds, and this year our battery weighs about 45 pounds. So that's a good amount of weight savings just for spending a little bit more money up front, and that will mean more miles at the end of the day. The biggest change between this year and last year is going to be our solar panel design. So like we've said over and over again, we are having an integrated solar panel on our car. If you've seen our car outside when you walked in, you might have seen that big aluminum rack that was on top. That was our solar panel, and we did it that way last year so we could take advantage of the full area we were given in the rules to generate the most power. But this year, we are breaking our solar panel up into this shape shown below. Each one of these sections with A, B, C, D, E, F, G is basically a different solar panel and is getting put into its own solar panel controller. So for example, E and F, these are going to be shaded depending on the time of the day, and we don't want those solar panels to affect the efficiency of all these other solar panels. So that's why we're breaking it up in this way, so we can mold it to our frame and create the most efficient solar panel possible. Another big change which we're making to our electrical system is our telemetry system. Like Jeremy said, last year we used a pre-built system which was originally meant for an electric bike, and while it did have all the sensors we need, such as shunts, hall sensors, and voltage sensors to get all the data we needed, this year we're doing a custom build solution based on an Arduino. So what we're doing is we're having all these different sensors plug into the Arduino itself, and then we are sending that data over radio rather than Wi-Fi, so we can have a clear and solid connection to our car at all times, rather than relying upon spotty cell service kind of in the middle of nowhere where the racetrack is at.
So last year our win was a combination of 5 main things: knowing the car, effective engineering, effective strategy, effective teamwork, and robust community support. So for knowing the car, again, we had miles before going to Texas, we had miles of tests to know the car and to know it inside and out. Effective engineering, we built the car around the forces that we were going to face on the track. So drag being the main one, we built the car to have a small frontal area to reduce drag. Effective strategy, we built a strategy that was based on the data coming from the car. So by using that data, we created a strategy that was effective and efficient for the entire race. Effective teamwork. So us being newcomers to Texas, we had to make specific roles and tasks for everybody in Texas to make sure that things ran smoothly on and off the track. And robust community support. We've received support from most people in the PNW. People who are generous enough to give their money, their time, their hours, and I guess their love to our team. So thank you for that.
So moving forward, we still have a lot of things to tackle this year, such as mounting motors to attaching solar arrays. If you would like to keep track of our progress, you can visit our website where our blogs are located. And one of the goals for each new year is to leave behind lessons learned and continue to build upon the success of past years. And so we do this through our notebooks, student mentorships, and tracking what worked and what didn't work.
Next year's competition is especially exciting. So instead of just going on the Texas Motor Speedway, we'll be driving from Fort Worth, Texas, all the way to Colorado. So we're going to be looking at very different lessons learned from that year. Things like different conditions. We're going to need more durable vehicles, team organization, unusual conditions, and a whole other slew of things that we're not expecting. So we'll be definitely reaching out to more teams, but we're really excited for this slightly different challenge as well as the opportunity to really apply this in a real world situation.
So So we will wrap up our presentation tonight with ways you can stay posted with our progress throughout the season. We have our team website and blog, and here's the address. So if you'd like to take a photo of this slide, you can see what we're up to as the season continues. And of course, we're on Instagram and Twitter. You can link from the website too for RAeS updates. And we're always looking for partnerships, mentorships, and sponsorships. So we have a table on your way out with our contact information and some other promotional material. Also, if you'd like to adopt a solar cell, we can help with that too. So thanks everyone, we really appreciate you hearing, and we also have one more interesting slide to show next.
As Max said, that we are wrapping up the planned part of our presentation and moving to the Q&A section. And so I anticipated a question that we would get multiple times, and I thought, they're gonna ask us, you're in Seattle and it's always cloudy here, it's always raining here. How does the solar car even do? Like, why is that even a thing? And here, this map shows the solar irradiance across the whole entire country. So clearly the Southwest gets the best solar power. And so you can see here that when we drive to Texas, we get the best results. We get better results than anything we get in the spring when we're testing our car up in Packard. But as you can see, it's not too bad where we get. It's light yellow, but it could be a lot worse. So we do get plenty of sun in the spring and get our power there. So solar cars are here to stay, and we're excited about that. And with that, we'll move to the rest of our Q&A session. So